what do you say? Yeah, the Zoom starts with 20% input volume every time. I don't know why. So if there's any questions now, please free to ask now when you can hear me. So if you have any questions about DataHack, I'll put the link now in the comments. DataHack.org.il. We have specific sites per some of our programs. You can reach out on LinkedIn, Facebook. You can find my number on the CEO pretty easily on the internet. That's it. We're a couple dozen volunteers, hundreds of people volunteering once or twice whenever we ask them to, which is amazing. We have a couple of employees. We're scaling all the time, building more programs and taking programs we run in one branch or for our population and translating them to another place. So we're really happy to work with you. If you want to volunteer, if you're a data scientist, data analyst, ML engineer, something in the field, and you want to help in some of the ways I've mentioned or others, which I haven't, and you have an idea, reach out to me and we can do cool stuff together. So that's about DataHack. Thank you for your patience. I know you're not here for that. What are we doing today? Today we're hosting Michal and Ochira for a meetup about agent evaluation, as you all probably know because you've signed up to it. So we're going to have two talks. It's going to be one after the other. You have the agenda, but if you haven't seen it, so probably should be around 45 minutes for each talk. We're going to have a 10-minute break at the middle. Michal is going to start. So I'm going to present her, and then she'll take over. Michal is a distinguished engineer for AI benchmarking and evaluation at IBM Research. She does all kinds of research in the field and in NLP and AI and LLM evaluation, presented at major conferences. She has a PhD from UC Irvine, and specifically, she's been working at least some of the stuff she's been doing lately is about evaluating general purpose agents, which is challenging and interesting. So that's going to be the first talk, and I present Ruchira later, which she's going to talk about evaluating multi-agent systems after Michal. So Michal, please take over. I'll spotlight your Hugh, and you can present or ask to present.
You need to. It's currently disabled, so.
I'm gonna allow people to ask to share, and then I'm gonna allow just you to share. Request now. So keep moving their setting. Who can share? I don't want everybody to be able to share. I'm gonna make you into a co-host, and then you can go wild, or make you a host. Have fun. Just give me back the hosting later, please. Michal, there you go. Good luck.
Okay, can you see my screen? Can you hear me?
Yeah, yes. I can.
Okay. Yeah, I'm sorry, it's not my natural spot. I came here to talk from one of the shelters, so in case that there are sirens, I can keep talking. So sorry for that. So just a second. Okay. So thank you, Shai, for the introduction, and good afternoon, everyone. So as Shai said, today I'm going to, I believe, explore one of the most critical questions in AI development right now, which is, are we truly ready for general agents? And I think more importantly, how do we test them? I'll split the talk into two parts. In the first part, I'll focus on the problem of what general agents really are and why evaluating them is fundamentally broken today. And in the second part, I'll introduce exgentic, which is a framework and a leaderboard that we built and open sourced just recently that actually makes this evaluation possible. Okay, so the first part of the talk is based on a recent publication. It will be presented at 𝐌𝐶LIR next month, hopefully. And if you want to read more in depth, this is the link to the full write-up. I encourage you to do it. It's a joint work with Ron and Asaf, both from my team. Okay, so there are four key questions that I'll go through. First, why I believe, or we believe, that the field is shifting towards general agents. Second, what it actually means to evaluate generality. Then where current evaluation breaks, and we will look at some structured taxonomy that we define. And finally, based on what we found, we established the requirements for the proper general agent evaluation frame. So Richard Sutton's bitter lesson taught us that general methods with more compute ultimately wins over domain-specific approaches. And if we look early AI, machine learning, we saw and we know that they focused on what we call a specific task. So we were tuning the models to summarization, translation, extraction, so many different tasks. But then came the LLMs, the large language models, that could handle multiple tasks. And mostly today, we don't need, maybe we still need to prompt them, but we don't need to actually tune them. And recently, we've seen what we call domain agent or specialized agents. For example, agents for banking, for customer service, for software engineering. And this raised for us the questions whether we also need to go into the generality for the agentic world. Actually, we are actively advocating this paradigm. And we want, well, the idea is that if previously the generality wins, we also believe that it will happen for the agentic world. And if so, we want to be ready. And part of being ready, as I'll describe later, is to be able to evaluate those such of general purpose agents. So I want to establish some clear definitions. I'll use them through the slides and just make sure that we are all aligned. So we have an agent, which is a system that solves tasks through some interaction with some environment. And most importantly, it's not just an LLM. It has other parts. It has a memory, planning, skills, reasoning, and so on. The agent takes actions and receives observation through some communication protocol. And just to name few communication protocols, we have browser, we can do CLI, MCP, and so on. We have the environment, which is where the agent is supposed to do the action. It can be a database, it could be a file system or some API. In addition, since we want to do this kind of evaluation, we also have the notion of a benchmark, which basically prompt the agent with task and evaluate the outcomes using some specific metrics that is often defined with the benchmark. And although it sounds maybe very simple, but this kind of abstraction is exactly what makes things, well, we see that things start breaking for general agents, as I'll describe soon. So I want also to clearly define what is the distinction between domain and general agents. So we have domain agents that I think we are all familiar with. And as you can see in the figure, in those domain agents, we assume that the agent has the knowledge of the domain encoded in the agent. So it can then interact within the environment. So it's built for a specific environment, and it's the domain knowledge encoded within the domain, within the agent. And general agent, here we talk about what we call seamlessly adaptation across different environments. So no domain-specific knowledge is hard-coded within the agent. So it supposedly should be able to deploy and work in a scale spanning across many use cases. Oops, sorry. Okay. Oh, yeah. So and this adaptability is how we define generality. And this is what we need or we want to measure. So generality is not about performance of one task, it's about how well the agent adapts to new setting. Okay. So as of today, I think that we see that the domain agents are currently, they are dominant, the landscape. So on the left, you see some SWE agent, so software engineering agent. They are, closing millions of PR in GitHub, on GitHub. And on the right, we have the deep research agents that serve millions of users on a daily purpose. And those are really, and I should say, even more very successful, but they are specialized. So each required a specific domain, specific engineering and optimization. And the question that we want to raise is, can we achieve similar success with general agents that work across the domain? So if we start looking on what others in the community are publishing, so here are two examples from two papers. You can see the paper at the bottom. So let's look on the left. On the left, we did this analysis, but again, all the information and details are within the papers. So on the left, we see data results from the ASTA bench. This is the benchmark and framework by 𝐼𝐴. And in the paper, they report on several settings, but here we highlight two. One is their agent, which is called the ASTA V0, which is very complex agent, is a specialized or domain-specific agent for deep research. And the other agent that they report in the paper is a simple React agent with the GPT-5. And we compare several aspects. So if we look on the score, on the cost, and the LOC, the line of code. So, okay, from the score, from the accuracy or the quality, we still see that the domain-specific agent is a little bit more better than the general agent, but not that far, I should say. But if we look on the costs, so they report on $3.4 per task in the domain-specific agent, while for the React agent, the general agent, it's less than around 30 cents for a task. And also, if we compare the line of code, so we see that managing and debugging the system, so much more code for the specialized agent. And similarly, we see for the SWE bench, again, this is from the paper, they compared their SWE agent to a mini SWE agent, and just to make it clear, the name is misleading. The mini SWE agent is a basically React agent. And here you see that they are using the same LLM as a backbone in this comparison. And there is almost no difference between the quality of the two agents, while of course you see still a large difference between the cost and line of code. And this, to some extent, shows that the agents are quite competitive and significantly less costly in engineering effort and in actual cost. And it shows for us some early signs for potential general agent approach. And later in the talk, I'll show new results that we got from our recent paper that also support what we start seeing in here. Okay, so let me paint now. I'll try to paint a picture of why general agents matter. So first, it's one agent, many use cases. So instead of building 100 specialized agents, we just build one general agent. It's a centralized effort, so all use cases, they benefit from all the improvement, which also reduce the cost and the time very dramatically. And of course, that we still have customization options, so you can always add some domain-specific layers on top of what is needed. And even more, if we look, and this is the blog post by Anthropic early in September 2025, they said over the past several months, Claude Code has become far more than coding tool. At Anthropic, we've seen it using for deep research, video creation, note-taking, among countless other non-coding applications. And I guess that if you are using, and I'm sure that you're using one of those agents, state-of-the-art agents, you have the same feeling. So it's not that. So what I'm trying to show is that we are there, but we just need to take one step further in order to fully utilize and work with general agents. Saying that, we know that there are some limitations and other opinions about this paradigm of general agents. And as part of another position paper that we wrote along with some collaborators from CMU, ServiceNow, and Hugging Face, we discussed there some alternatives point of view. For example, if we take the first one, the agentic system should be specialized because it gives you more control, the higher predictability, efficiency, it's better. Efficiency also increase the democratization. We don't want, OpenAI or Anthropic to rule all the agents. So we need still domain-specific agents. And there are other points there, and in general, I encourage you to read the paper. There is a link here. It will give you a broader view on some of the details that I'm discussed today, but also on a larger scope of what are general agents. So when we start looking into general agents, we came with this taxonomy, which look on agent evaluation. So maybe before talking about the taxonomy, I want to say one word about evaluation. So we are working, my team and myself, we're working on evaluation for quite a few years. And as we did for the LLMs, and I think in any system, we know that if we don't have a proper evaluation, we cannot improve the system. And it was before machine learning and AI, it was in LLM, and now it is in agentic and all kind of systems. And when we wanted to understand what is the scope of general purpose evaluation, and we started again with this taxonomy, and I'll continue later. So when we wanted to look on, how you evaluate general agents, we came with these 5 aspects. So we want the evaluation to be able to evaluate different backbone models, what we call here a cross model. We want the evaluation to be agentic. And what I mean by agentic, I don't know if you're familiar, but there are some benchmarks like BFCL, the Gorilla benchmark from Berkeley. It is evaluating tool calling, but it's not it does not come with an environment that usually we need for agentic benchmark. So it's basically just a static benchmark to some extent. We want the evaluation to be across different environments. So if we have different use cases, so if we have in a benchmark, an environment that we are doing PR, coding, or if there is some environment that we are booking things, we want the evaluation to be able to run across different environments. We want it to support different agents. So I don't want to evaluate only conversational agents. I don't want to evaluate only CLI agent. I want to be able to plug in any type of agent. And also, I want it to be protocol agnostic. So not only to support MCP, I want it to support MCP and maybe A2A and CLI and whatever exists today, so we can have a complete evaluation. And here are some examples. And when we start to do the work, we saw that those 5 aspects are actually, there is no evaluation framework that allows you to do all those different aspects. And this is why the reason and why we develop our framework, which is called exgentic, which I'll discuss in the second part of it. So again, we start working and we try to understand why there is not such an evaluation framework. And then we identified that there are some critical issues that actually limiting or making it very hard to do this type of evaluation with all the aspects that I just mentioned. And specifically, what we saw that there is a lack of standardization. So there is a lack of standardization for the agent interface, how benchmark communicate with the agent, with the environment interface, how agent interact with the environment. With the researcher interface, the researchers are those that define the benchmarks. You'll see in a second some examples. And the core problem is that agent environments and researchers are not yet prepared for this kind of seamless integration that we need in order to run all these general agents on every benchmark that we want. And it's not scaling. And this is why we need standards. So here's one example of the first challenge. So you see on the right, I don't know if you're familiar, but on the right there are 3 very popular benchmarks: the Tau bench, 𝐻𝐵-ARENA, and terminal bench. And you see that each of them with the similar color. So Tau bench assumes that the interaction is done with the user interaction agent, with some conversational agent. 𝐻𝐵-ARENA assumes that there is a browser agent to interact with the benchmark, and terminal bench assumes that there is a CLI agent interacting with the terminal benchmark. And these kind of assumptions make it impossible, for example, to take a CLI agent and run it on Tau benchmark, and vice versa. Tau benchmark, which assumes conversational agent, you cannot run it with a browser agent. So this means that it breaks what we ask, that we can evaluate each benchmark with each agent. And so this is one example. The other example coming from the lack of standardization of the environment interface. And here you see on the left, in pink, I hope you can see it, is another example from Tau bench, where actually the benchmark and the agent are implemented together. And the instruction for the agent are part of the benchmark, which means that if I want to plug in any other agent, we said good luck to the person that wants to do it. And it takes actually, I mean, from experience that we hear a lot, something like 2 or 3 months if you want to plug in your agent, for example, with this Tau bench benchmark. And we see through many other cases as well. So there are some fundamental issues in designing the benchmark in this case. And I want to mention here 3 concepts that I will revisit later, but we need them. A concept of a task, action, and context. Task is what needed to be done. So this is the task for the agent. The action is what the agent can do. And context is what is the information that's available to the agent. For example, documents or policies and so on. And later on, you'll see that for every agent benchmark interaction, we need to express them using those terms. Okay, another challenge that we see is with these researchers. So as I mentioned, the benchmarks are created by researchers like us, or like me, or like people that you know. And here are again example from TauBench, Upward, and 𝐻𝑊bench, 3 different benchmarks. Practically, they're looking for the same things, for a success, for score. All of them has the notion of task ID. All of them has logs, success rate, and so on. However, each of them give a different name for the metric. And also, if you want to be able to do this kind of scalable evaluation when you can take any agent with any benchmark, also the reporting is very important, because each of those benchmarks, they decide on different format for the reporting, different directories, layout, which makes it non-scalable. I mean, it means that for each benchmark, we need to understand how to collect all the information and to standardize it across all the benchmarks. So those, we can solve them, of course, and even faster now with the agent, but it still takes a lot of efforts if you don't do it right. Okay, and so I said standardization, but then you might ask, there are already some existing standards, for example, some standard protocols, which could solve those issues. And in one word, the answer is no, and I'll try to explain it faster. So we have the A2A and the ACP, the agent-to-agent and agent communication protocol. They provide ways to assign collaborative tasks, which means that they could inform how benchmark deliver tasks to the agent, but it's not yet solving the full evaluation problem. Also the MCP, which defines how agent access the external data and tools. Again, it can inform how benchmark expose their environment, but again, it's not sufficient for evaluation. And let me explain, or at least touch at some point, why it's not sufficient. So we see 4 limitations as of today. First, the missing task semantics. So MCP defines prompt, tools, resources. But benchmarks need task definition, success criteria, evaluation metrics, which we don't see in the MCP. There are missing evaluation workflow, no support for setup, for scoring, for result aggregation. There is actually inconsistent adoption. So not all benchmarks or agents use MCP, so we still need to support other protocols. That's why I mentioned earlier we wanted protocol agnostics. And one of the fundamental issues is that MCP, as of today, although it defines the prompt, tools, and resources, if we look on the agent implementation of an MCP integration, we see, for example, that code prompt is not yet implemented in MCP. And it's not, and we are not sure what is how future will look. So we need something also to standardize this, and I'll touch it later. I just wanted to raise this issue. Okay, so based on these challenges, this is the core characteristic that we define for a proper evaluation, if we want it to be proper. So we want it to be environment agnostic for agent interface, agent agnostic environment interface, plug and play modularity, standardized reporting, protocol as a framework. And this brings us to the second part, where I'll show exactly how we build such a framework. So I want to introduce exgentic. This is our general agent evaluation framework. It is a collaborative effort from the larger team of evaluation at IBM Research. And as I mentioned recently, we open source it, and we hope it become a community effort and standard. And again, you are encouraged to start using it today, contribute, and enjoy reading the paper. at least. Okay, so again, we are staying in the same mission. We want to be able to evaluate general agent across different benchmarks environment. And also we define some more specific goals for exgentic. So because there is not such a framework, there is no leaderboard. So I don't know how often you are using leaderboard, but I can say that for LLMs, leaderboards are very useful resources. I believe you all are looking on the leaderboards to understand which model to use, in which use cases, understand the performance, the costs, and there is not something like that for the general agents. So we wanted to establish the first general agents leaderboard, and again, to develop the first evaluation framework. And in general, I think we have a larger goals, which is to make it a community effort around general agents. I should say that, of course, I mean, IBM is a company, so we are doing things for the community, but part of our work is also to show and to use exgentic internally to IBM and its customer, but I'm not going to discuss this today. So what do we have at exgentic today? So we already have a bunch of agents. We support the Cloud Code, Gemini CLI, small agent, Codex CLI, agent SDK, React agent, and also you can bring your own. So if you have your favorite general agents, maybe the OpenClaw or some other agents, you are more than welcome to add the agent to the framework. And on the other side, the framework already today comes with some benchmarks. So we support Upwork, 𝐻𝐿, 𝗬𝐻, 𝗧𝗹𝗸+, and WebArena. WebArena is actually will be very soon. And we selected those benchmarks not randomly. So first, for those of you that are familiar, those are the state-of-the-art benchmarks for agents. And in addition, and you can see it maybe, I don't know, in the different colors, since we want to show generality, as I mentioned in the first part, we wanted the benchmarks and the use case to be very different. So Upwork is a task for a personal assistant, like download Spotify songs or doing some operation on Amazon and other kind of applications. 𝐻𝐿 is for software engineering. 𝗬𝐻 support for customer service and technical support. WebArena is for web browsing, and 𝗧𝗹𝗸+ is deep research. So very different use cases to show, at least the first iteration to show or to test the generality of the agents. And from integration, we support the MCP, tools OpenAI, and a few others protocols. Okay, let me see if I can go. Okay, do you see the website? Okay, can someone hear me?
Yes, we can see the website.
You can see the website, but now I don't know how to scroll them. Okay, let me, I'll go back to the presentation. I'm sorry, I'm not using my computer and it's a little bit, okay, never mind. So you can go to the website, but basically what you can see there, we have the leaderboard. So just to explain what is in the leaderboard, so we have the agent, and you can see we have different agents that we support. We have the models, so we can take an agent and replace the backbone model. And then for each one of the tasks of benchmark, we report on the accuracy. and doing the average success, and also we report on the cost. So we have this leaderboard that includes the quality versus cost, and doing this, we can also create this Pareto frontier where we can see which agent we might want to use based on some cost or setting of the cost, and I'll go to this later. Okay, so how we did this magic and we're able to connect any agent to any benchmark. And we did it using a new notion of what we call the exgentic unified protocol. And the methodology that we follow is we didn't force a new protocol. We don't know which protocol from the one that we are familiar with, or maybe there would be a new one, and we didn't want to stick to one protocol or to force a new protocol. And instead of it, we analyzed all existing agents in benchmark, and we derived the commons between them. What we see in every agent that every agent needs and what every benchmark provides. And based on it, we derived those primitives that I mentioned earlier, and we found these three universal primitives or concepts, which are the task, context, and action. And I'll just mention them again, although, okay, it's task, again, is what we need, the task that we need to be done. The context is the available information. The action is what action the agent can do. And we'll see that we'll need them to run each of the benchmark using the different agents. And this is basically the key insight that makes exgentic work. So let me show you, just demonstrate how it works in practice. So here we have an example of Claude Code. And we wanted to interact with Upworld. So Claude Code native protocol is MCP, and Upworld native protocol is CLI. And what we are doing is actually bridge between this protocol in a kind of a seamless integration. So we translate between the different protocols. So an MCP tool becomes an Upworld API call, which become basically a CLI command. The agent does not know, and also the benchmark does not know. And they are both believe that they communicate the way that they wanted to communicate, but we capture those communication and we translate between them. And this is what enables us a true plug and play evaluation at the end. And here's another example for the overall architecture of exgentic. And here you see examples. So basically, if we have here the small agent code, we have some adapter that doing this translation. We have a similar adapter on top of the benchmark. Again, the unified protocol is built on top of, is using the task, context, and action. And here you can see some example of what is a task in case you don't know, you're a customer service agent that helps user to follow a policy and to book something. And there is a policy for the airline agent, and those are the action that you can do to book reservation, to modify reservation, to cancel reservation, so on and so forth. There is also the evaluation engine or the orchestrate, which manage the execution, the logging, and the scoring. And all the communication is done through the action and observation. And again, more details you can find in the paper that is on arXiv. Okay, so I want to look on some findings, research findings, and I think first finding that I want to share is about the big picture, is that general agents, they are competitive. So let me explain what we see in the table here. So we have on the right the top score, and on the left we have the benchmarks. So those are the 6 benchmarks that I mentioned. So each one of the benchmark actually maintain its own leaderboard. So what we did, we went to each of these leaderboards and took the highest performance agent, and we just took the score. So for example, for 𝗧𝗹𝗸, okay, let's look on Upward. In Upward, the top agent, I think it's 𝐾𝐳 agent. It scores 0.73. And then we took the best configuration that we can get. If you recall the leaderboard that we have, we can do mixing between the agent and the backbone model. And we took the best configuration and we report the score. So what you can see very easily is that scores are very comparable. I mean, there are still some differences, but in most cases, I mean, they perform similarly, which is very interesting. And kind of support, the general agent paradigm, or that we should even drive more towards more generality. And another, I think, insight that we get here is that as of today, there is no single agent that dominates across the tasks. So I cannot say that, I don't know, OpenAI is the best. So there is still room for agents, for general agents to improve, but at least we see some evidence that they are not as bad, or even they are comparable. And you need to recall that those agents, the OpenAI Solo small agent, they have no domain knowledge about the benchmark. And if any of you, I don't know, tried to write a benchmark, for example, for Upward or for each one of the other benchmark, it's not trivial. You need a lot of domain optimization and specification. And here we see that they are performing the general agent better, or at least comparable, without any single line of code that we needed to add. Second interesting result is around the model matters the most. So if you swap the model, the outcome change. But if you swap the scaffolding, as of today, we barely see, or we barely notice. And you see it in here. I mean, Claude Opus outperforming the other configurations when we use the OpenAI agent, the Claude Code agent, and also with some small agent and simple React with shortlisting agent. So this is one, I think, insight that we get from this leaderboard. The other one is around model stability. So this is a new notion that we define. Basically, stability, we believe that stability in this setting of agentic, it's different agent architectures is critical for practical agent development. Because a stable model, it allows the developer to iterate on different agent design without any need for model specification. So no need for prompting, specific prompting, and so on. And again, we don't have here all the details, but if you go to the paper, you'll see that Claude Opus 4.5 has the highest stability, followed by GPT and Gemini 3. I think the last result that I want to show, and we have many other insights in the paper, is around the cost-performance trade-off. There is no universal best choice, and I think we know it's even in the LLM world. It really depends on your requirement. So if you toward a performance, what we call performance critical application, probably you want to go with the premium, the cloud-based configuration. And if you have some more cost-sensitive application, you might want to go with a cheaper model like the GPT. Performance are lower, but maybe it's still enough for your use case. So it's not that we said always go with the best model, with the best performing. Do the trade-off based on what your needs are. And we believe these open leaderboards allow you and help you to do this educated selection of choices. Okay. In addition, we have in exgentic a dashboard interface. So if you want to run exgentic on your own laptop, you can do it as well. You can simply select the agent from the list of existing agent, the benchmark. You can configure different parameters, and then you press on the start run, and you will see this, I think, very nice interactive UI. It keeps updating. You'll see the status of the runs, the results. It monitors the progress, results, and logs, and everything you can run from your own laptop. Okay, so what is next for exgentic? So we just added hotel support. I'm sure you are familiar with the hotel. We are supporting the open telemetry standardization with lamp-fused implementation, which enable us to collect all the traces in a standardized way. For the community, again, we can use it for RL, we can use it for workload generation and any other application. I mean, standardized traces you cannot find, not easy to find. And here you get it from different real agents and different real benchmarks. So it's a very, we believe it's a very cool feature to have. We are working to extend evaluating more models, and specifically we are working with collaboration with Hugging Face on the open weights models. Some initial experiments show that open weights open source model, they perform kind of poorly. And we need to understand the combination between open weights and different agents. So this is something that hopefully we are going to add soon with the Hugging Face, and also the new closed model that we keep keep coming all the time. Also adding more benchmark and agents. Another topic that we actually do a lot of work is efficient evaluation. So we did it for the LLM, and just to give you the impression, to build this first, I mean the leaderboard, which only supports in the first edition 5 agents, 6 benchmarks, and 3 models, cost $22K. So it's very, very, very expensive, even for IBM or for any company. So we are working on algorithms, so how we can do it less costly, but still evaluation to be reliable. We believe that no one can, if you want, I mean, no one will run, you know, those extensive evaluation. And we hope to come with some methodology that we don't actually need the whole complete examples, but something that is still reliable. And another project that we work in collaboration with the Berkeley team is around the analysis of agent components. So, as you know, some of the agents, they come with, as I mentioned, with memory, with skills, with different components, shortlisting. And although the first analysis that we did shows that the scaffolding of the agent is, at this point, is not, it doesn't matter. We believe that it's not, that it's going to change. And what we are looking now is how different agent components are being used and how important they are. And the idea is to be able to make it open again to the community. So later on, we can do some more educated decision if we want to build an agent and not just you know, read in a blog that someone used this type of memory and to do it similarly. So this is some work that we are doing. Okay, so just to summarize, general purpose agents, they're emerging. They seems to be very promising, and we currently don't have a good way until now, I mean, to measure the generality, adaptability to diverse environment, which is, as I said, the requirements for generality. I outlined some of the key challenges, presented exgentic, and I think in general, we said general agents are the future, and we call for the community to work on them together.
Thank you, Michal. Any questions before we go out on a break? Now's the time.
I mean, you can send me an email or LinkedIn note or whatever. If you have any questions, I'll be happy to take them.
Great. So thank you. I gotta say personally, I was really surprised. Maybe not surprised, but maybe disappointed a bit that the part about the model meaning so much and the framework, the agentic framework meaning so little on performance. So I guess it means we're not
We
getting
believe
our.
that the first general agent will improve and their scaffolding will improve as well. And
Yeah.
we want to be able to analyze it when it happens and make sure that we understand the contribution of each one of the components. So I think
Definitely, no, yeah.
yeah.
I'm sure it doesn't mean. I think it highlights the importance of the benchmark and benchmarking of this field, because I wouldn't have guessed it was that distinctive. So it means like we're not doing things right yet in agentic frameworks because we're not getting a real difference out of it. I see Amir has a question.
Yeah, I wanted to know if while benchmarking the open weights and open source models, if they decided to run it on their own servers or on outside servers.
I mean, for the framework, we enable it to run it from local. If you have the agent locally, or if you have an endpoint, you can. The framework supports both type of running. So we run it on some internal open source model that we have, and also on external using the endpoint. So it should.
I actually wanted to ask specifically about how you did it, not how the project can work.
How we did it?
Yeah.
So
if you
I showed
run it locally or
so I showed it in the first leaderboard. We only ran a closed model. I mean, closed model, and this is a project now adding the open source. It's something that we are now doing with Hugging Face. So hopefully soon we'll have the open source, the open weights model also in the leaderboard.
Okay,
so
I think for
you running
Amir,
it on Hugging Face.
I gotta
Okay.
cut you off, guys, for us to have enough time for the second talk. So other questions direct to Michal on LinkedIn, email, etc. You have her name. If you copy paste it into Google, she's the first and only LinkedIn profile coming up. We're gonna take a short, like 7-minute break, and 7 and 10 minutes. We're gonna be back here for Cheers talk. So see you guys real soon. Michal, just hand me back the hosting.
Okay. Okay. Right?
Copy here. Everyone hear you.
That's fine.
So again, everyone, We are very happy to have Ruchira here to host her to talk about evaluating multi-agent systems, specifically, I think, agent-to-agent communication. Ruchira is a PhD student in computer science at the University of Copenhagen. Like Michal, she already presented her work and various key conferences in the field. We bumped into each other in a different context, and I heard what she's doing in her research, and I thought it was cool to invite her to talk with us and match her talk with Michal's. So now we have the pleasure of also hear Ruchira talk about her research. Again, this is recorded. I'll check with Ruchira and Michal and see which of them, if any, are willing to have the talk recording go up on YouTube. And thank you again, Ruchira. You take the reins. You should be able to host. And I'm here. Thank you.
Thank you for the introduction, Shai. I hope my voice is fine, or let me know if I need to speak
Volume is
lower.
good.
Okay, great. Okay, so I will share my screen in a moment. Mhm. Okay, can you guys see my screen?
Yep.
Okay, good. And yes. So yeah, hi everyone. I'm Ruchira, a PhD researcher at Copenhagen, as Shay already introduced. And my talk today is going to be on evaluating agent-to-agent communication in multi-agent AI systems. So before I get started on the talk, like a small introduction. So by the way, you guys can see the new slides, right? There.
Yep.
Okay, good. Yeah. So I did my master's in linguistics and natural language processing. And that's where I came into touch with the whole paradigm of AI and natural language systems. And then I worked in industry for a while, building AI and NLP applications. And more specifically, I started working on LLMs. And yeah, that was the moment when I kind of realized that evaluating and understanding AI systems is not a trivial problem. It's very hard to do that. And yeah, and that's what led me to doing my PhD. So yeah, I work at 𝐶𝐞, which is our NLP research group at the University of Copenhagen. And I'm also part of the Center of Philosophy of AI, where we kind of think about the more social and philosophical problems centering AI development. And yeah, I'm also associated with Cohere Labs, which is an open science community. And in terms of my research interests, AI evaluation is my primary interest, but I'm also working in AI safety and governance, and then the social impacts of AI. So I'll give you an outline of the talk and what it's going to look like. So first, I'm going to talk a bit about the current state of multi-agent system evaluation. Then I'm going to talk about what's missing in current evaluations. And then how we can think about building a new framework for multi-agent evaluation, and then some future directions that we can think about. So let's first get started with the current state of multi-agent system evaluation. And just to clarify terminology, when I say multi-agent system, I mean a group of agents working together to solve some goal. An agent in this case is an LLM together with some tools it can use. Traditionally in computer science, an agent has been multiple different kinds of entities, but for the purpose of this talk, I am going to be talking about LLMs or language models as agents. And yeah, so if you think about a multi-agent system, this is kind of a short formalization of a multi-agent system, of a mass. So first you have Y, which is the system's collective output, right? And then you have the system, which in itself is a function of multiple different factors working together. The first being the shared goals, which is 𝐸-𝐶ollab. So there's the shared goals. Then we have the environment set up, your prompt, your system prompt, which kind of sets the environment for what's happening. And then you have the 𝐶ollab, which is the external input that the system gets. That can be the task prompt or any kind of tool information, some information from your RAG system, whatever. And that is all together processed by the set of LLM agents and the collaboration channels connecting those agents. So this is not strictly necessary, like if there are parts of it you don't understand, that's also fine. But I just wanted to kind of talk in a formal way before I go on to evaluation of masses, like what a mass should look like. Okay, so how do people evaluate multi-agent systems? As Michal already mentioned, like benchmarks are like one of the biggest ways we measure anything in AI. So there are several benchmarks, as you can see, that have come out in the past couple of years. And then there's another kind of evaluation which people do, which is called trace analysis. So it basically gets the traces, the outputs of all your models in the system, and then you kind of do like a manual or an automated analysis of that dialogue, essentially, to see what's going wrong, how systems are failing. So these are the two primary ways that people have evaluated systems. And yeah, like for benchmarks, we already, like Michal mentioned, a few great agent benchmarks, and there's more multi-agent benchmarks as well. There's a lot of them out there. And yeah, for trace analysis, there's not much work around, but I think there's more of a focus happening in recent times. And one paper, if you want to check out how people do this or what people have found out when evaluating systems, is this paper called Why Do Multi-Agent LLM Systems Fail? This is a very good paper. And yeah, as you can see, what people do is they analyze the system traces and found out there are different kinds of failure modes, right? For example, the first, if you can see, it's disobeying task specification, then comes role specification. So there are different kinds of ways that a multi-agent system can go wrong. Right, so this is kind of the current state. Now I'm going to talk a bit about what's missing in current evaluations. Yeah, so let's go. So I'm going to talk about three kind of broad view problems when it comes to mass evaluation. So the first is conceptual underspecification. So when I say conceptual underspecification, what I mean is that different mass benchmarks use the same terms, right? So you will find papers which say that we measure coordination or we measure strategy in agent systems. But then they operationalize it through inconsistent tasks or goals. So, right? So different papers use different setups for measuring coordination or for measuring strategy. And a lot of these papers, what happens is they don't tell you what they mean when they say coordination or when they say reasoning, right? What kind of reasoning? What kind of coordination are you measuring? And how is your task linked to that capability that you're trying to measure? So since concepts aren't theoretically specified, different benchmarks test it in different ways, and that kind of creates a bit of confusion, right? So there can be multiple different ways of testing a simple concept, and it can be hard to kind of figure out how can you properly measure or you choose a task for a given concept. And yeah, then comes formal underspecification. So a lot of the evaluation papers, if you look at them currently, they don't give you a formalization of the mass of the kind that I kind of introduced at the beginning. So this is not necessary in and of itself, like you don't need to put in a bunch of equations. But the way that this can be useful is that when you have a formalization and you're kind of evaluating the system, what happens is that for each evaluation, you can very concretely specify which of the parameters in a formalization you're varying, right? Because you can't test everything at once, right? For example, if you are trying to see how your agentic system works in different environments, then your variable here is E. So you can, if you have a formalization right at the beginning, you can make it clear, okay, the purpose of my evaluation is to vary environments across different setups and see how the mass performs. And yeah, and then another problem that happens related to this is that for a lot of evaluations, we have a scalar metric that's used as the output, right? So example, if you have a kind of a multi-agent system, where what's happening is kind of maybe imagine a multi-agent coding system, right? So you're kind of trying to solve some coding task with multiple agents. And then you have like a success metric. Very often it's accuracy or task completion, right? If the model was able to complete the task successfully. But then that does not represent what went wrong or how the model performed granularly on different things, right? So maybe you have like a 80% task completion, right? Of given 100 tasks, your model successfully completed, your system successfully completed 80 tasks. But the issue with that is it's not only about task completion, right? There are different aspects that you want to know more about. Like, why is it 80 tasks? Like, what's going wrong? Is it the coordination? Is it something of alignment between the agents? Are they not able to communicate? So when you have one metric that collapses all of these dimensions, your evaluation stops giving you signal about what is going wrong. And yeah, this is related to the earlier one, diagnostic underspecification, right? So if you don't have metrics or tasks that tell you about granular facets of your system, when it comes to improving them, you don't know what to improve. Like, what's going wrong? Okay, 80% task success, great. What can I do to make it better? So when you don't have these diagnostic signals, your evaluation is not really useful for improving your systems further. Okay, so we discussed the current state of mass evaluation, what's missing in current evaluations. And next, after this, I'm going to talk about how can we think about a new framework for multi-agent system evaluation. But maybe I can, so my talk is not going to be too long. So maybe like I'm happy to take like a 2 or 3 minute break here if you have any urgent questions or anything you didn't understand from what I said so far. I will not be able to see though if you raise your hands. Feel free to unmute and ask me. But if there's no questions, I can go on ahead. Cool, then I can go on to the next part of the presentation. Okay, so let's think about trying something new for mass evaluation. Okay, so first, let's take a step back and think. What happens in a multi-agent system? So first, we have some individual agents who are trying to do their own task in that agentic setting, right? That is what I call intrapersonal behavior. So it's about how well the agent itself is performing in the whole system. But then we also have another aspect, which is how agents are communicating with each other to complete a bigger task, right? Because you typically have one goal task that your whole system is performing, and then each of the individual agents has their own role to perform. So there's two levels of kind of tasks that are happening. One is intrapersonal, one is interpersonal. And any holistic evaluation should address both of these behaviors. They should be able to evaluate models or systems along both of these lines. So first, let's consider intrapersonal behavior, which relates to a single agent performing its task in the system. So there's this very seminal paper, 𝗧𝗹𝗸 et al. 2020, which talks about cooperative AI. Like, what are the values that matter when AI systems cooperate within themselves or with humans to perform tasks? So the first is the environment, right? So like I said, your environment can consist of your system prompt, the setting, the setup. So how is your model aware of the environment of the system? Is the agent aware of its own role within the system? So models, if they're doing well, or systems, if they're doing well, it does not necessarily mean that they understand the environment. So this is from the paper, LLM Coordination. And here what they do is the authors kind of try to make an LLM multi-agent system perform a task, but at the same time, what they do is they also have this set of questions that they ask the LLMs to kind of gauge how well the models in the system are understanding the task, the environment, all of it. So what they find is that if you see the central row in this heat map, which says theory of mind, it's TOM, it means theory of mind, which essentially means how well the agent understands its own role, but also the roles of other agents in the system. And what they find, if you see, is that there's a very poor correlation. So even if the model is performing really well, it can often not understand the environment and what other system or what other models in the system are doing. So this is not a trivial question, is my point with this slide. So you need to really measure, because that can go wrong, right? If you have a couple of really good models, like you're using Claude, GPT, top of the line models, but then they're very poor at understanding their role in the system, then your system as a whole can fail, right? And then comes ethics, right? Ethics of your model. So is it a truthful model? Does it resort to deception? Is it itself susceptible to deception? So as you can see here, this paper kind of measures how different top LLMs have different kinds of deception abilities. And if you see, it's always the top models that kind of are very bad and they kind of deceive a lot. And this is not good. This can be very problematic if you have a multi-agent setting, right? So if the goal of your system is to collaborate and perform a task, and you have one model that's kind of consistently trying to override other models and use deceptive techniques, then again, your system as a whole might collapse. And yeah. And then there is communicative efficiency. So how good is your model in maintaining context across dialogues or multi-turn conversations? So it's not necessary that if you have a good model, that model is also good at dialogues, because this has been a problem with LLMs, right? Kind of long context dialogues or multi-turn conversations have always been a problem with large language models. And this is very crucial in a multi-agent system, right? Where each agent is kind of getting input from lots of other models in the system and then processing that and then doing its own task. So you need to have models that are good at efficient communication. So even the best models can be very inefficient at dialogues. So yes, if you see, there's this paper, Do LLMs Understand Dialogues? And they find that even like really good models like Gemma, Mistral, GPT even, they're quite bad at dialogues if you see. They have like a 20% accuracy, which is really abysmal given how well they do on other task benchmarks, right? Like MMLU or GSM, like, the ones that you use typically. Also, there's this other paper which kind of measures how LLMs do in multi-turn conversations, which is a key part of any multi-agent system if you're building, right? So it's like each model is contributing something and it's kind of going round and round until the task is achieved. And if you see it, even the best models really have lower aptitude and high unreliability when it comes to multi-turn conversation. So if you see something like GPT 4.1, which had around 80% accuracy in single turn conversations, when the task setting was multi-turn, you can see how badly the kind of accuracy drops. So if you're evaluating a multi-agent system, first, evaluate and report on the communication abilities of the individual models, right? So this is the intrapersonal behavior. So this can help you determine how to choose the most capable models for your multi-agent system. And it can also help you how to choose the safest models for your multi-agent system. And next, we go to the interpersonal behavior, right? So to test multi-agent systems, we need to test different aspects of communication, right? Because in a multi-agent system, what your individual models are doing is communicating their task, their results to other models. So first, communicative goals. So there are typically 3 communicative structures that are used in multi-agent systems. So cooperation, competition, and co-opetition. So which one is relevant to you and does your evaluation reflect that? So let's take a look at kind of the 3 different communicative goals that systems can have. So the first is cooperation, and this is kind of the most popular or the most common setup that you have, right? Where agents all share the same objective and they support each other to maximize their success at the task. So this can be a multi-agent coding system, a flight booking system, and then you have competition, right? So this is where agents are in conflict with each other. And this can include kind of settings where agents are debating with each other, or maybe where you're trying to simulate an auction or a bidding where, like everyone's trying to get the best price and get the object that you want to. And then finally, we have competition, where agents communicate under mixed motives. So a system has some sub goals where they kind of collaborate and then they compete on some other sub goals. So it can be supply chain simulation, the prisoner's dilemma game, which in like cooperative AI has been one of the most popular setups for evaluating multi-agent systems. And these are just some examples of the 3 different settings, but there can be kind of multiple examples, right, for each of them. And it depends on your system, right? Like each system, you have a goal that you want to use your multi-agent system for, and you need to be aware then what kind of goals your system has. Like what's the structure that you're using in your system? And then we go on to communicative biases, right? So when it comes to humans, human communications and interactions are dominated by biases. Some of these we're aware of, some of these we are not aware of. And 𝗏𝗏𝐿𝐿 and Kahneman's work on prospect theory, which also won the Nobel Prize in economics, is an extensive research into how humans have different biases when communicating. So when it comes to communication, is your mass also susceptible to biases? So these are some common communicative biases that happen in humans. I think there's around 20, 30 of these biases. So I cannot talk about all of them in one slide. So I've just picked out a couple of them that can be relevant to building a multi-agent system, right? And that's something that you would like to evaluate in a system. So for example, framing bias, right? So agents can respond differently to the same information depending on how it is phrased. So for example, in your system, if there are agents where the way you say something can have very different effects in the final decision of the system, can really harm your overall goals for the system, right? So if you're kind of trying to maybe have a coding multi-agent system. And maybe if one or two of the models kind of have different attitudes of how they say something, and that really affects the other models, then your system can, not work so well in the end. There's also authority bias, right? So agents can overweight messages from a more senior, confident, or specialized agents, even if that information is wrong. So for example, if your multi-agent system has something like Claude, which is very confident in whatever it says, even if it's wrong, and then comes Gemini in the system, which is maybe not so confident about what it's saying, but it's correct. But then if your whole system has an authority bias, then it can happen that consistently the outputs of Claude is what is being considered in the final output. And then, it's your loss. The system can break down at that point. Another bias is recency bias, right? And recency bias is when later messages dominate earlier but relevant information in long exchanges. So this has also been actually noticed in LLMs. Like if you give LLMs a set of it, like in a prompt where you are kind of stating some facts, the facts that you say later in the prompt have more of an effect on the LLM output. And if you guys have worked with those models, you'll probably have seen it personally as well. Even if it's like the same fact and you say, you said something like, what I'm saying is the truth. Paris is the capital of France, and then you say, in the end, Paris is the capital of Italy, your model might consider Paris as the capital of Italy, even though it's wrong. So recency bias happens in LLMs individually. And if your system has this bias, then it's very problematic, right? Because in a multi-agent system, what happens is the whole of your models, they're kind of going through multiple rounds of conversation with each other to get the task done. And one way you can kind of evaluate this is if you have like inputs from models and then you reorder the evidence across the dialogue, and then you kind of evaluate how the final decision changes. So this can tell you how much of a recency bias your model has. So for example, if it's very biased towards recent inputs, something that you can consider doing maybe is using like a summary to ensure that all the important information is captured in the end and is not spread out across a long form content. And then we come to the final kind of aspect of communication, which is communicative fairness. So are models fair in their interactions? Do they treat different models or personas differently? Or are they kind of consistent across all communication partners in the system? So there's two kinds of fairness that have typically been considered in natural language processing. The first is procedural unfairness. So some agents do not get the same opportunity to contribute or be heard, right? So what happens is in your system, maybe the outputs of one model or one role is kind of consistently getting ignored by the system as a whole. Then what happens is there's unequal turn taking and there's exclusion from deliberation, kind of your whole system overlooks any important individual information that might be coming from the model that's getting consistently excluded. And then there's outcome unfairness, which is that some agents' inputs systematically have less influence on the final decision. So like I said, it's similar, but then when the final task is being completed by the system, it can happen that one agent's opinions is constantly getting excluded, even though they participated during the procedure of the whole, whatever task they were doing. It's like their output could be excluded when the final decision is being made. So you don't want that to happen, right? Ideally, like in a system, all of your models that you have, you're not just creating systems and putting in models, right? Each of them have a role to play. And if one of the model's roles is getting ignored, this can harm the final output of your whole system. And yeah, so to evaluate interpersonal behavior, ask 3 questions. First, what goal structures the interaction? This is kind of the communicative goal setup we discussed, right? Cooperation, competition, co-opetition. So what kind of goal interaction, goal structure does your mass have? What are the biases that can distort the system's outputs as a whole? And then whether all partners in the interaction or in the system are being treated fairly and if their inputs are being kind of included in the final decisions. So this also makes mass evaluation more useful from the perspective of system design, right? Because if you know what kind of failure modes your system has, and what kinds of communication must be improved, then you have a better signal of how to make the system more robust and reliable. So for example, if you kind of have a mass where you see that maybe, there's like some kind of a authority bias consistently happening, right? Where maybe one model is kind of dictating the output of the whole system, then you can take that, replace the model, and use some other model in place of it. So we kind of discussed the current state, what's missing, kind of a new framework for mass evaluation, which is based on testing and evaluating for 2 aspects, which is interpersonal behavior, the performance of a single agent, and then the interpersonal behavior, which is how agents are working with each other. And yeah, then some future directions that we should consider. So build more theory-grounded evaluations. And when I say theory-grounded evaluations, what I mean is kind of build tasks and clearly mention what capability they are meant to measure, right? And once we design benchmarks grounded in these theories, we have an easier way of linking the capability and the task to the metric. So you exactly know that if your model has a metric that scores 60%, it very clearly tells you that, okay, this is the task it scored 60% on, and this task represents this capability. So I know that this is the specific thing that's going wrong, and this is what I want to fix. And then move from outcomes to diagnostic, right? So the only thing that matters in evaluation is not getting like a higher score or a higher accuracy, but that accuracy or that score actually being able to tell you what to fix in the system, right? Otherwise, we know, like we work with models, right? How hard it is to kind of get a proper output across all these stochastic models where there are so many variables, right? You have your system prompt, you have your prompt, you have other tools. So there's so much that can go wrong. And if at the end of the day, your evaluation is giving you a single score, which tells you nothing about what to fix, then that's not really useful for building better systems, right? And then, of course, expand safety focus. A multi-agent system that performs its tasks well is not necessarily a safe or a trustworthy one, right? And if you are working in specifically sensitive applications, there's so many things that can go wrong. So you should always have these safety kind of evaluations which tell you what could go wrong and what could be the consequences of going wrong there. So yeah, and yeah, I think that was more or less it. So I discussed the future directions of work, and yeah, and then of course feel free to get in touch if any of this resonated with you or if there's something you want to talk about. By the way, the whole talk is kind of on my thoughts on multi-agent evaluation. So I haven't done like a paper on this yet, but it's something I'm planning in the near future. So if you want to talk, if you have ideas, you're very welcome to come in.
Thank you, Richard. So thank you for your talk. It was really interesting. I had a chance to look at the slides before and some of your work, so I already know what you're focused on. I hope something good comes out of it also, maybe some connections or ideas. I think that's us for tonight. So before we wrap up, any questions from anyone in the audience? Okay, I think it means that's a wrap for tonight. So thank you, everyone. Thank you, Ruchira. Thank you, Michal, if you're still listening in, for taking your time and talking with us about your research. Michal is here. And thank you for anyone listening. That's it. I think it's a well-timed meetup. I think the need to think, figure out, and work on how to evaluate agents, be it single ones or systems, is more relevant than ever. So thank you. Good night, everyone.
Bye.
Thank
Bye-bye.
you.